So solving right triangles with trig ratios was something that you spent some time with in geometry. So what we're doing today is really a review of skills from geometry. When you're asked to solve a triangle, it means that you want to do what our objective is for the day. You want to find all the missing sides and all the missing angles. So that's your responsibility for your homework tonight, to solve the triangle, to find everything that's missing. If you think back to that triangle brainstorm we did on the first day back, a lot of people said for triangles they have 3 sides and they have 3 angles. So that means you have a total of 6 things that you have to make sure you know the measures of. You have to make sure all angles are known and all sides are known. You're usually given 3 things right off the bat: the right angle, one other angle, and a side. Okay, and then you have to find the others. So here's our first example, and I'll give you some time to copy it down. Example 1, solve triangle ABC. And I have it as a whole picture. Things are filled in, and we're going to solve for everything that's missing. So for right now, just kind of copy that into your notes so you have a nice example to look at. Triangle drawn. And we want to solve the triangle, find all the missing sides and all the missing angles. One thing I like to do at the beginning of a problem is just kind of figure out what I'm responsible for, like what things are missing that I'm going to have to find. So when I look in the inside of my triangle at my angles, I know C is 90, I know B is 62. I'm responsible for identifying the measure of A. So I'm going to write up here, I'm going to need to know what angle A is. And then when I look around the outside of my triangle for my side lengths, I only know side A is 6, so I have to find side B and C. Once I say what all of those things are equal to, then I'll have finished my problem. And I can move on to the next one. So now I'm going to put it out there to you guys. Do you have any strategies for finding any of those missing items? Jackson, you got one?
For the angle one, you have to find out what angles you need, because all the angles equal 180.
Okay, excellent. All the angles in a triangle are supposed to equal 180. A lot of us wrote that down in our triangle brainstorm. So you have to figure out what's the value of A that makes that equal 180. Does anybody, how would you go about doing that, Kylie?
Add 62 and 90, and then subtract it from 180.
Okay, so you might add 62 and 90 together, and then whatever that sum is, you're going to subtract it from 180. So mathematically, I could write a numerical statement that looks like this. Other people might say they would start with 180, and you would just subtract both of the angles. Subtract 62. Subtract 90, what's left over must be what makes 180. Does anybody have a different way they might find A? I like to think of it as a shortcut. Let me just, this is totally fine if you use 180. You'll get the correct answer. If you do this, we get what, 28? Okay. So 28 is the correct measure for A, and if you choose to use the 180 method, that is totally okay. It works. I will say there is some knowledge that you could use from geometry. Did you have an idea, or you're just thinking back? What?
Me?
Yeah.
Well, you could subtract 90 from 62.
Switch the way you said it, but subtract 62 from 90.
Oh, yeah.
And tell us why you would, Jace, maybe just do 90 minus 62. How do you know you're allowed to do that and still get the correct answer, 28?
Because 90 is half of 180, so then if you subtract it, you can
When you think about the fact that we're doing it with the right triangle, right? One of the angles is 90. And Jace is saying if you take away that one right angle, which the triangle has, the rest of the angles have to add up to 90. So there was a theorem last year in geometry, and I don't know what the name of the theorem is, but the theorem said the two acute angles in a right triangle are always complementary, meaning they always add up to 90. So I use a shortcut when I'm finding my missing angle. I always just do 90 minus the angle that I know, because that immediately gives me my other angle. All I'm doing is I'm taking out the piece where I factor in the 90. But I'm going to come up with the same answer. If you don't like this 90 minus 28, you don't have to do it. Okay? They're really the same thing. Okay, so either one works, whatever one you're more comfortable with. Okay, so we've got A, and now we're left to find B and C. So what I'm going to have you do is have a quick chat with your shoulder buddy or the people around you and see if you can come up with anything you remember doing in geometry that would allow you to solve for one side of a right triangle if you only know one other side. So I think we could all argue here Pythagorean theorem at this point isn't going to cut it. We need another side. So talk to your group or talk to your shoulder buddy. Think about the things that we've been studying the past 2 days. They might be helpful. And then we'll kind of reconvene and we'll see what we come up with. So have a quick chat. I'll give you about a minute or so. Okay, well, let's come back and have a chat. Did you come up with anything? I heard from Jackson already today. I want to hear from someone else. Sierra.
Like plugging the side that you have to SOHCAHTOA.
Oh, SOHCAHTOA. We have been spending some time with SOHCAHTOA, right? Okay, good. So I'm glad you guys remember that. So you're saying, do SOHCAHTOA, and you're saying plug the side you know into SOHCAHTOA. So that would be side 6. And can you
Well, then you just have to pick an angle that you saw.
oh, okay. So here's one of the tricky parts, and this is nice because you'll have some time to work on this in class today. And you have to own the problem, and you have to say, all right, I'm going to choose angle A, or I'm going to start from angle B. It doesn't matter which one you choose to go to. Sometimes one might make your life a little bit easier than the other one, so you might think about working smarter, not harder. Okay? But it doesn't really matter in the end which one you want to choose. Which angle should we work from, Cole? A or B? It doesn't matter.
No.
Which one do you want?
B.
Cole says B, so we're going to go to angle B. And we're going to work from angle B, which is 62 degrees. And then that's how you label your sides, is what you're trying to tell us here, right?
Yeah. So then it would be cosine of 62. Yeah, cosine of 62. 6/6.
Okay, so let me kind of back it up. So Sierra remembers using SOHCAHTOA, you're going to use the side that you know, which is side 6, and you have to go to one of the angles, and from that angle, 62 or B that Cole chose for us, we should label the sides appropriately, like opposite, adjacent, hypotenuse. Okay. Now, know that if you're labeling adjacent with just A, that's a totally different A than we have for side A, right? Okay, so I usually use my 3-letter substitute or 3-letter abbreviations. So the side opposite of angle B is side B. That's my opposite. 6 is my adjacent side, the other leg. And then C is always my hypotenuse. And so, Sierra, you were kind of saying, maybe I'm going to work this out in a little bit slower. you have to use the side that you know, which is side 6, correct? And that's the adjacent side. So when you look at SOHCAHTOA, which one doesn't work at all? You cannot use so. Okay. So does not have an adjacent side in it, therefore you would not pick sine. You're going to narrow your choices to cosine or tangent. Now, Sierra chose cosine, and she chose cosine so that she could solve for C. If you chose to use tangent, you would be solving for the other letter B. Either one of those are acceptable. But I agree with Sierra's work. Cosine is supposed to be adjacent over hypotenuse, and that's 6 over C in our triangle. Now, how do you solve for C?
You have to get the decimal, or the cosine of 62.
Okay, you might do the cosine of 62, and that's where our calculator work comes in. So let's do that. Type cosine of 62 into your calculator. Zero point 4694.
5.
4695.
4695 if we round up. It shouldn't make that big of a difference on the 10,000. Okay, then how do you solve for C?
You multiply it by 6, or... Why do you put it over 1?
Oh, so you want to put the 0.4695 over 1? Does that help anybody? What might you do next? Okay, you could cross multiply here. So some teachers will teach people to cross multiply, which works great. I like cross multiply actually for this. Okay, but that works just great. So if we cross multiply, we'll get 0.4695C equals 6. And then how do you get C all by itself? Divide. So you're really dividing 6 by the cosine of 62, which we got as a decimal. So then we'll divide by 0.4695. And what is C? 12.8. Questions about that process that we went through? Where any of our numbers came from or why we did what we did? There are variations to that solving. Like you do not have to change cosine of 62 into a decimal right away. You could leave it as cosine of 62 and put it over 1 like Lauren did and cross multiply with that. And you would just have C times cosine 62 equals 6 and then divide by cosine 62. Totally fine. Okay, so now if we know that C is 12.8, can we find B, the other missing side? Trace, you're shaking your head yes. What tool might you use to find your one missing side now? Kylie, remember, she'll help you.
Yeah.
Pythagorean theorem. Okay, use your good old friend, the Pythagorean theorem. Once you find one of the missing sides, Pythagorean theorem, you should be good to go. So let's use Pythagorean theorem to find that missing side. Okay. A squared plus B squared equals C squared. And we know we're looking for B, so we know 6 squared plus B squared equals 12.8 squared. Subtract your 6 squared from both sides. And you'll come up with whatever 12.8 squared minus 6 squared is. I get 127.84. And then I have to take the square root of that number. And I get 11.3 for B. If you want to write out 6 squared is 36 and 12.8 squared is whatever that is, and then subtract 36, if that's better for you, you can do that. I just don't want to write out those numbers. Okay. So you get the same answer that I get. And then if I go back and I fill in that 11.3, I'm going to see I found everything I was supposed to find. I found 11.3. So I found all the missing pieces. Okay, in the next example, this is what your homework assignment problems are going to look like. Notice that this is set up just a little bit differently. I don't already have the triangle labeled for you. So in the book, it's going to say, use this triangle for all the problems. Triangle A, B, C. And then your separate problems are just going to give you two pieces of information, an angle and a side length. And then it will be your job to find the missing angle and the missing two sides. Okay, and that's what I want you to work on right now. If you need to bounce ideas off of your shoulder buddy or people around you, if you're having trouble with that trig ratio part, I'll be walking around the room and I can answer questions for you. I would recommend to get started, draw yourself a new picture and label the new triangle, okay, where angle A is 33 and side C is 10. Okay, so I'm going to come around and I'm going to check your answers. Please be working on, get started on the first homework assignment, which we need to do in class because we're having difficulties. So you need to get stuff answered if you can't remember from geometry. This is a skill you've done before. You just have to push yourself. You're coming back from winter break. We're all a little bit tired, but you all have the knowledge and you all can do it. Okay. So what I would do on this problem, if I were starting it, I would start by solving for angle B, where I just take 90 minus 33, and that gives me 57. And I can now label 57 degrees and 33 degrees. I'm also going to label that C is 10 over here. Okay. The next piece is that trig piece that Sierra gave us, and this requires you to take charge of the problem. You have to choose an angle. I don't care if you choose 33 or 57. If you feel confused about me talking about working smarter, not harder, then you just always pick an angle without really thinking too much about it. And if you have to work harder, you have to work harder. Okay? If you can troubleshoot that, then go ahead and do that. But in the beginning, you might just start by always picking the same angle. So for example, I saw a lot of people as I went around who chose A, maybe because it was the angle that was given to them. They chose 33. Once you pick that angle, you must label your sides opposite adjacent hypotenuse. The side that is opposite angle A is little a. You should always be able to identify your hypotenuse because it's across from the right angle. And then the remaining side is your adjacent side. Now here's where we can use our trig, our SOHCAHTOA. In order to solve for one of these missing sides, A or B, I must use the side that I know. So I do know that C is equal to 10, and that's the hypotenuse. That means when I choose to set up my trig, I must use one of these ratios that has hypotenuse. Tangent will not be used to solve for my missing side. I will use the hypotenuse. Whether you choose sine or cosine depends on which letter you're going to solve for. If you want to solve for a first, that's opposite. You'll use opposite and hypotenuse, so you're going to go with sine. Okay. The sine of 33 is equal to a over 10. Your job is to get a all by itself. If it's being divided by 10, you use the inverse operation and multiply both sides by 10. So you should come up with something like a equals 5.45. This piece right here, the trig piece, this is what I want you to concentrate on during work time. Make sure that you're getting to that piece. Make sure that you're trying to work through that piece. And make sure that you're asking questions if you're not sure how to set it up. Do not leave this room without getting the questions you need answered. After that, you could do Pythagorean theorem.
I have a question about the Pythagorean. Now that we're measuring, can we take the square root of the decimal and round?
Yes.
Once we get the square root?
No, now you should take the square root of it. So like, we would do something like 5.45 squared plus b squared equals 10 squared. And then you subtract this 5.45 squared from both sides. And I saw, is it like 70 something? 70?
Well, I did it.
A different one. What is this one? 70.39. But yes, put the square root of 70.9 in there and get 8.4, or you would be getting 5.4. Good. Okay, I want you to get started on your homework assignments so that you can ask me questions before you leave.